So let's prove that root 2 is irrational. And the method that we are using here is called proof by contradiction. Proof by contradiction means that we start with the opposite assumption. Whatever we are trying to prove, we will assume the opposite, and then somewhere in the process we'll find that there is a problem of what we have assumed. There is a problem arising due to the assumption that we have made. So the logical conclusion will be that the assumption is incorrect, and hence what we have assumed, the opposite has to be true. So when we are trying to prove that root 2 is irrational, we will start by assuming that let root 2 is rational. And then we will try to see that there is a problem with this assumption. Now the moment I assume root 2 is irrational, that means root 2 can be written in the form of a by b. So root 2 is equal to a by b, where a and b belongs to set of integers, b is not 0, and a and b are coprime. We have seen the meaning of coprime in the previous video. So this is the key here, that whenever we have a rational number, the a by b format can always be written as two coprime numbers. So here we will see that somehow when we write root 2 as a by b, a and b can never be coprime. That is the key concept here. Let's see exactly how. So let's take this equation root 2 equal to a by b. Let's square both sides of the equation. So root 2 square is equal to 2, and a by b whole square is a square by b square. Now I can write a square is equal to 2b square. I just move the b square on that side so that a square can be written as 2b square. Now the moment I write a square equal to 2b square, that means a square is a number which is 2 times of something else. So definitely a square is divisible by 2. And in the previous video we saw that this always means that a is divisible by 2. So this is statement number 1, that the number a is divisible by 2. Now whenever I say that a is divisible by 2, I can always write a equals to 2 times of some other number. Let's say that some other number is an integer c. So if a, I can write it as 2c. I can square both sides to say that a square equals to 2c square. Now 2c square is same as 4c square. So a square is equal to 4c square. I had an equation previously which stated that a square equal to 2b square, and now I'm saying a square equal to 4c square. So if I look at these two equations, the left side is equal. So I can say that the right sides are also equal. So 2b square is equal to 4c square. Divide 2 on both the sides, I will get b square equal to 2c square. Now I have a number b square which is 2 times of some other number. So I can claim that b square is divisible by 2. And the moment I say that, I can say b is also divisible by 2. So this is statement number 2, that b is divisible by 2. What was the first statement? A is divisible by 2. So from statement 1 and 2, I will say that a and b have a common factor. What is the common factor? 2. A is divisible by 2, b is divisible by 2. So a and b have a common factor 2. So that means a and b are not coprime. But in the beginning I have claimed that a and b are coprime. So that means there is some sort of a contradiction happening. I claimed something but I am saying something else. So we will say that this contradiction arises due to our incorrect assumption. The problem started the moment I assumed that root 2 is irrational. So this assumption is incorrect. So the only logical conclusion is that therefore root 2 is not rational. So root 2 is irrational.